Hi, and welcome to Chapter 11, the cardiovascular system. And we're going to start with blood. Now, blood will be a really important part of your work. It seems like blood tests are always part of patient diagnoses, and so I'm sure you'll be needing to understand a lot of this chapter. So let's begin. Let's start with some functions of the blood. Right? So if we just look first at the term cardiovascular, cardio means heart, vascular means vessels, blood vessels. And of course, within blood vessels and the heart, we have the blood. So let's take a look at what blood can do. All right. So it can transport. And that's what it is. It's a giant transport system. If you think about it, oxygen, nutrients, from the food we eat, waste products, regulatory molecules such as hormones and enzymes and other things that are needed to regulate the body. These are transported through uh, the cardiovascular system. And all these things must, especially like oxygen, it has to go to every cell of the body. And just think of that task of having to transport blood, carrying these things to every cell of the body. All right. Regulation of pH and osmosis. We have molecules in our body that help to maintain water balance in our body. And then buffers that regulate our pH. Body temperature regulation. We can make blood vessels dilate or expand to bring more blood to, let's say, the skin surface, and that will carry heat away from the body as the blood and the warm blood is exposed to the near the surface of the skin. So, when you're hot, that's why your face gets red, right? Because blood vessels dilate and it carries heat away from the body. And on the flip side of that, we can constrict our blood vessels and prevent blood from going to certain places to keep the warmth in our body. Protection, immunity. We'll talk about immunity when we get to the lymphatic system a little bit more, but there are immune cells, white blood cells that are located within our blood and can help protect our body. Clot formation. Okay, we get a cut, we got a clot so we don't bleed to death. And there are clotting disorders. There's disorders, genetic disorders, hemophilia, where people don't have the proper clotting factors in their blood. And so they don't have that ability to clot. And now, then there's the flip side, right? Too much clotting can clog vessels and block blood flow to these cells, and so those cells die. So that's kind of has to be balanced. All right, let's take a look at the components. So, what are the components of blood? So let's write them out, and then I'll bring up some pictures here. Okay, we'll start out with, well, let's just do it all in one shot. And remember, these diagrams, these images you can get from the images. I do post them, and so go into the ungraded resources, and you'll find the images there. So let's take a look. Now, if we took blood from a person and put it in, let's say, a tube like this, and either let it sit for a while or spun it. We can put it in a machine called a centrifuge, and it will spin the blood and separate the components. So the bigger components, the bigger, heavier molecules will settle to the bottom as that force pushes it out. It's kind of like, going on one of those rides where you're sitting next to somebody that spins around like this, and you sit, and what happens? Everything gets pushed to the outside. So you squash the person who's sitting on the outside. And it's the same thing. This force pushes the bigger things to the outside. And so, and the lighter things without as many molecules, heavy molecules, are, on the other side. So And so this is what happens. It separates out. The cells, mainly red blood cells, are located here on the bottom. In between, there's a little area called the buffy coat. Let me make it a little bigger so we can see. The buffy coat here in between contains white blood cells, platelets, which we'll talk about in a moment. And then we have plasma. The clear portion is plasma. All right. Mainly water. Look at 91% water. We do have some proteins and other things that are dissolved in it. All right, so those are the components of the blood. All right, so plasma here, formed elements. So formed elements are these what we used to call cells. You know, back in my day, we would say blood is made up of plasma and cells. Well, then they found out that platelets are not actually cells, they're pieces of cells. So they had to get away, get away from the word cells and use what's called formed elements. All right, which includes red blood cells, white blood cells, and then the little platelets. And we'll look at some other terms that you might see instead of red, white, and platelets. All right, and so this is the breakdown of more of the things that are found in, let's say, the plasma. The specific proteins that help with clotting, fibrinogens, important in clotting, globulins. Immunoglobulins are immune system, right? These are antibodies, and albumins are proteins that are important in balancing water in different parts of the body. Then nutrients, ions, waste products, gases, regulatory substances like hormones. These are all located up in the plasma. All right. We'll talk about the white blood cells and separate them out into its different components. Okay. Let's continue. So let's take a look at red blood cells. The other term for red blood cells is called erythrocytes. Erythrocytes. And so you need to be familiar with both of those terms because there's conditions that have that term erythrocyte in it, or there's a hormones that contain the word erythrocyte in it. Okay, there's a hormone called erythropoietin. So you need to know that term. So when you see that, okay, erythropoietin, you know that it's a hormone that deals with red blood cells, right? And so it's understanding all the terms. So don't get stuck in just learning one name. Oh, and I put a few kind of basic functions here. Erythrocytes transports oxygen. Leukocytes defends the body. This is our, part of our immune system. And then thrombocytes are the platelets for blood clotting. All right. So erythrocyte, leukocyte. Leuko means white and cyte means cell. So those are white blood cells. Thrombocytes are the platelets. Okay. So, know both these names. So, when you hear the term leukemia, right, it has something to do with the white blood cells. Okay. If you never learn that term, you won't recognize that and what it is. And when you take like board exams and stuff, you have to be able to pick up and understand terms that you may have never heard of before based on the terminology, your understanding of the root words and things like that. And that's why, when you take, or if you've taken the medical terminology class, really pay attention because that's going to help you to understand those terms that you have never heard of before. If you understand what the words, mean, where they come from, right? Find words that you already know that you can apply that to, right? It's about understanding the language instead of just memorizing. And I'll say that a lot. Don't memorize. Do not memorize. It's way too much information. Try to understand the words instead. All right, so let's take a look at red blood cells. Let me get that information. There's a lot here to red blood cells, and we'll talk about it all. Okay, so there's a this is a multi-question question. The first part is describe the structure and function of erythrocytes, including the molecule hemoglobin. So let's first describe what it looks like. Red blood cells are biconcave discs. Biconcave discs. So if we look at it here, what it means, it's just thinner in the middle. So if you think about a donut without the center punched completely through, right? So it's a donut with the hole that's an indentation, but not quite poked through. And that's what it is. It's thinner on the inside. So when you look at it here, it's like an inner tube without the hole completely, all the way through. All right, and so when we look at it, so biconcave, it's concave on both sides. Kind of a funny thing. And it carries oxygen. Another thing about it, maybe go down. It lacks a nucleus. Okay, so it's a cell whose function is to carry oxygen. And it does that by getting rid of everything it can in the cell, excuse me, um, so it has more room to carry oxygen, right? And how does it carry oxygen? It has to have an affinity or something to bind to, and that something to bind to is called hemoglobin. So hemoglobin is a protein that has iron in it, and it's this protein with the iron that the oxygen binds, to which the oxygen binds. All right. And so that's why iron is an important, part of our diet, part of our, makeup. It's part, a component of every one of our red blood cells and allows us to bind oxygen. All right. Um, so we answered the first part, molecule hemoglobin. Where are they produced? So they're produced in the bone marrow. That process is called erythropoiesis. Poiesis means the beginning or to create, to make. So it makes red blood cells, erythrocytes. That's the process. Okay. What is this process called? It's called erythropoiesis. All right. And what is the function and how is it regulated? All right. So let's take a look first. There's one more thing I want to talk about. A measurement that you will encounter all the time. All right, that's called the hematocrit. The hematocrit is the percentage of red blood cells in the blood. Let me just kind of draw that really quickly. So when you do a hematocrit, okay, they're gonna take a sample of blood. Okay, and so they're gonna fill the tube up, let's say, with blood, and they centrifuge it. And so when it centrifuges, as I mentioned before, it's going to separate into its components. And this lower part will be the red blood cells. So these are the red blood cells, the erythrocytes. And so if we look at the percentage of erythrocytes in the whole blood, that would be the hematocrit. So anytime they do blood work, okay, which, they do a lot, they're going to get a hematocrit score. Another name is packed cell volume, PCV, you might see that as. Hematocrit is the percentage of red blood cells, erythrocytes, in the blood. Okay, so in this case, it would be about 50% in that person. Normal will be about 38% to maybe 52% or something like that. Of course, it varies a lot from person to person. So who would have a higher hematocrit, males or females? It would be males, okay? Because females are menstruating. Well, a menstruating female, I should say. So females menstruate, and so they lose blood. And so their hematocrits are a little smaller. So let's say someone comes in and you do hematocrit. My sister's a physician. She said a guy came in and he had complaints and he actually this was the third time he came in. His wife said, he kept saying he didn't feel well, but he was the type to not want to go in. So, but she made him go in because she knew something was wrong. And and so my sister said, okay, and then she took some blood and she was doing the blood work. She sent him home and she's doing the blood work. She's spinning it down, waiting for it because, then she can go home. And then when she took it out, it was like this. Okay. It was like, I think, what did she say? It was like 18%, which is and then she recalls, then she thought about it. Yeah, he was kind of pale. It's because he didn't have any blood in his body. I mean, red blood cells. So she called him. She sent him to the hospital. She met him there. Then when they did tests and everything, they found out he had lung cancer. So I think he got treated, and I like to think she saved his life. But anyway, because the previous doctor he had seen did not pick it up. He gave him antibiotics once. He gave him an inhaler once because he was having trouble breathing, and um, and didn't follow through. And the third time when he saw her, she did the work and knew that there was something wrong. So anyway, so the hematocrit would be 18%, and then that would make you go, oh, okay. So again, you're going to encounter these types of measurements, and to understand what does that mean is going to be very important. Okay, let's go back. All right, so hematocrit is percent of red blood cells in the blood. All right, now let's talk about regulation. How do we regulate it? Because obviously we need a certain amount of red blood cells in our blood, okay, to carry oxygen. So when we need more red blood cells, let's say we go up in altitude. All right. So when we go up in altitude, have you ever heard of the term the air is thin? Well, it just means there's less oxygen in the air. And so you need a certain amount of oxygen in your body, right? So how do you deal with low oxygen environment? Your body detects, hey, there's not enough oxygen. What do? You make more red blood cells to be able to carry more of the oxygen that there is in the atmosphere. Okay? So there are mechanisms to detect low oxygen. Your body, well then, here we go. The kidneys will secrete a hormone called erythropoietin. And automatically, if you see this term, erythro, you know it has something to do with red blood cells. All right. So erythropoietin is actually a hormone secreted by your kidneys, which will cause the bone marrow to make more red blood cells. Erythropoiesis will occur. All right. So you make some more red blood cells, and then you can carry more oxygen just because you have more red blood cells. Okay. That's one way to regulate the amount of oxygen that you carry in your body. You keep it at homeostasis, right? All right, let's talk about how do you use this information. Let's see if you're an athlete. How do you use this information? Because the more oxygen you can carry, right, the more um, cellular respiration can happen and the more ATP you produce. So there's a direct link to the amount of oxygen that you carry and the amount of energy you produce. All right. So the more oxygen you carry, the more ATP you make, the longer you can run, the farther you can bike. So it's very important. So let's talk about how to use that information. And some people have used it illegally. All right. So first, let's talk about natural conditioning. So people who know this information go, well, let's say if I go and train at a high altitude, then I can produce a little bit more red blood cells. And then if I go down and then run my race, okay, I'll have a little bit more red blood cells in my blood if I can do it, between, within 120 days when, before those red blood cells die. So you go down and you run your race after being high altitude. And then you get a little bit of an advantage, right? You get a little bit more red blood cells to be able to carry more oxygen to go a little further. But you can take it to an extreme, right? That's called blood doping. So blood doping is an illegal way to artificially increase your hematocrit, your red blood cells. So there's different ways to blood dope. What I just talked about, that some people call it natural blood doping, and that's not illegal. But if you do it significantly, raise your red blood cells significantly, that would be illegal. So some have removed their red blood cells prior to a race and then re-injected them. Right? That would increase your red blood cells. Some athletes have taken synthetic erythropoietin called epogen, and that's a hormone, right? That you could take and it increases your red blood cells. Now, they have epogen in the hospitals because to help people to stimulate red blood cell production, people who have low, red blood cell count, like called anemia, then you can stimulate red blood cell production. But there is a danger that comes with doing these things, and your blood can be thick. It can be thickened with too many cells in it, and it can block small capillaries and cause strokes and death. So, you have to be really careful with what you do. All right, let's continue on. Let's go on to the white blood cells. So there are different types of white blood cells. And of course, we know that the function of the leukocytes is to protect our body. It's one of the functions, defend our body. There are 5 types of white blood cells, and we can separate them into 2 groups, one with granules and a group without granules. So we call them granulocytes and agranulocytes. A means without, or. So if you see the term A, the prefix A, it usually means, less or without something. So granulocytes and agranulocytes. So let's grab that. And we'll talk about them briefly, and then I'll show you a picture. So the ones that contain granules are the neutrophils, the eosinophils, and the basophils. And these are the percentages of, the percentage found in the blood. So as we see, neutrophils are by far the most common of the white blood cells. They are phagocytes. Okay, they eat things. Phagocytosis is the process of eating. So these guys, will eat bacteria, it'll eat debris, dead cells, in your body. They kind of housekeep in there to get rid of just stuff lying around. Eosinophils, you have about 2 to 4%, so not many. These are important in allergic reactions. And they have certain characteristics. Neutrophil stains with a neutral stain. Eosinophil stains with a dye called eosin, and it stains it red or bright pink. And basophils, we don't see many basophils, less than 1%, and they release histamine and heparin in inflammation. So when you have an inflammatory response, we'll talk about that later. Inflammation, you get a cut and it's inflamed, you get inflammation, or just sometimes people get inflammation abnormally in their body. What happens? It gets red, it gets, what else do we think about? Weepy, kind of, maybe swell, right? So those are caused by these chemicals that are released. Histamine causes these reactions, leaky blood vessels, blood vessel dilation to bring more blood to the area, hence the redness. And then swelling will be due to leaky capillaries. So, meaning stuff can leave the vessels and make their way into the tissues. And why is that good? How is that promoting health? Well, white blood cells then can leave the blood vessels. It's easier for them to get into the tissues and to fight, these phagocytes to come out and fight. All right. But the basophils can help that. They all have lobe nuclei, and I'll show you what that looks like in just a second. And basophils stain a dark purple with a lot of granules in it. Neutrophils have not a ton of granules compared to the eosinophils and the basophils. Agranulocytes are the lymphocytes and the monocytes. So lymphocytes are the second most common white blood cell. Okay. So be careful if I ask what is the most common formed element. That would be red blood cells, right? What would be the most common leukocyte? That would be the neutrophil. All right. So you have to, if I ask those questions, to look very carefully. So lymphocytes are 20 to 25% of all white blood cells. So there's a lot of them. And these are important in immune response, in our immunity. We'll talk more about them, specifically their role. And there's different types of lymphocytes too. Monocytes, 4 to 8%. These are big phagocytes. We call them big eaters. Okay. They turn into things called macrophages. So monocytes become something called a macrophage, which just eats a lot of things. It plays a very important role in immunity. All right, let's take a look at the pictures. This would be like a blood slide. And all right, so there's just like a typical blood slide here. Maybe I'll make it bigger. Oops. All right, so we see here, by far, erythrocytes are the most common. Erythrocytes, notice they're a little more lighter on the inside. It's because it's, that biconcave disc. And then platelets are these pieces here of cells. Those are the platelets. And then these would be the leukocytes. All right, so these two are neutrophils. This is a lymphocyte, and this is a monocyte. So there's very distinctive characteristics of each. And one of my jobs in college was I worked for an animal hospital, and I took blood samples and I looked at the blood of dogs and cats. And I would count the percentage of each one of the white blood cells and see if they fell within these percentages. If they didn't, then, and really mainly I was looking for an increase in eosinophils. Because in animals, and even in humans too, it's also an indication of parasites. So, parasitic infections. And so when there's a lot of parasites, you get a rise in eosinophils, which would be an allergic kind of reaction. All right, so that was kind of one of the things that I did. So I got pretty good at identifying blood slides, and it was fun. All right, so here it shows you the different ones because this picture here doesn't have all of the white blood cells or the leukocytes. So let's take a peek. All right, here are the granulocytes, the neutrophil. See how they're all lobed? It's hard to see on this one, but they are lobed here. A few granules in there, the neutrophil. The eosinophil is stained with eosin, which is a red or pink stain. All right, so we get pink granules, very distinctive. And then the dark purple granules in here for the basophils. Lymphocytes are small. They're the smallest of the white blood cells, and we can compare them to the size of the erythrocyte. So they're small, not quite the size of the erythrocyte, but they're smaller than these other ones. And the nuclei are round to oval, and they take up most of the space. All right. And then the monocytes are bigger, and they have kind of a kidney bean nucleus like this. And actually the cytoplasm is a little like cloudy looking. All right, anyway, those are the leukocytes. and they all play an important role. All right, then let's take a look at the thrombocytes. So the thrombocytes are important for blood clotting. Blood clotting is a very um, complicated series of events that happen and involving different kinds of proteins and things like that, what we call clotting factors. And so I'm not going to go through that process. If you go on to physiology, you'll go through that process. But here, the only thing you need to really know is that thrombocytes or platelets are the formed element, and they're actually cell fragments. And that's it. All right, so let's move on. We're going to talk about blood typing. Again, something that you're going to encounter, right? People's blood types and what type of blood you can give to different people in different circumstances. So let's go ahead. It says, what's the difference between the ABO blood group and the RH blood group? And the difference is based on the surface proteins called antigens. So on cells, there are markers on cells. I have markers on my cells, you have markers on your cells that distinguish between self, like these are my cells, versus somebody else's cells. These markers are called antigens. And so if I try to put my cells into you, my markers, my antigens will be detected by your body, your immune system, and say, hey, that's foreign. All right. It's a protective thing. And so that's why, like transplants and stuff like that, you want to match those markers, those surface markers. And when we did the cell membrane, you looked at things that stuck out of the membrane. Those are part of those are markers. All right. All right. So they're just different markers on red blood cells, different antigens on the red blood cell surface. So there is two blood typing systems. And so when when you give a blood type, like my blood type is A positive, the A is part of the ABO blood grouping, and the positive is part of the ARH blood group. All right. And we just put it together to make, a complete blood type. So let's go ahead and I'm going to, before I give you the complicated diagram. All right, let's take a look at blood typing. So ABO, if we look at and what does that mean? These are just terms they give to the different types of antigens. So if you are A type blood, what does that mean? So this is the type, and then the antigen, which means on your red blood cell surface, you have the A antigen on it. All right, it's just a protein that they identified and they called it A. Okay. If you have B type blood, what does that mean? It just means on your red blood cells, you have a different antigen. We'll call it the B antigen, just a different protein. All right. What's another blood type? Another blood type is AB. So what do you think that might have? Some people say, oh, is it an AB blood type, an antigen, AB blood antigen? No, it's actually the A and B antigen. So this person has markers, both of the markers. And then the last type of blood is O type blood. O type blood, think zero. There are no antigens. No ABO antigens. No AB antigens. All right. Does that make sense? Now let's take a look at what does this mean for individuals. So I am A-type blood. So that means I can receive A-type blood. right? Because if someone puts A type blood, it's not foreign and I don't attack it. If someone puts in B type blood in my body, what do? It's foreign. I attack it. Okay. And I get rid of it. And what happens is it clumps up. They call it agglutination because the antibodies, attach to the markers and then it causes the red blood cells to clump up together. So again, that's called agglutination. And that's bad. How about the AB blood type? If someone puts an AB blood type in my body, what will I do? Hey, I don't recognize that. I'm going to attack it, right? It might not be as severe as the B type blood, but I'm still going to attack that. What happens if someone puts an O type blood in my body? There's no antigens. I don't see it as foreign, so I can accept that. So O type blood is what we call the universal donor. Okay. Universal donor. Because you can give it to anybody and it won't cause a reaction. Does that make sense? All right. Um, who would be the universal recipient? Meaning they can receive any. That would be the AB person. So in their blood, they have both A and B antigens. So if you put the A blood type, hey, they already have it. It's not foreign. If you put the B type in an AB, they already have the B, not foreign. If they put the O type, okay, not foreign. So this would be the universal recipient. O-type blood is very valuable. So if you have O-type blood, and we're going to do the other blood typing, okay, we haven't really finished our typing because there's more to the story. But if you have O-type blood, the blood banks will give you gifts to go donate blood. All right. So, if you want gifts like movie tickets and things like that, then check out the blood bank. We'll check to see what your blood type is, right? Is this important? Yeah, it's important. I mean, we kind of just, here we go and they'll test for these things and make sure we don't get the wrong type of blood. But if you're like out in the boonies or somewhere where they don't have regular medicine, then you might want to know what your blood type is. Okay, so you can say, hey, give me, AB positive or whatever. All right. All right. The other blood typing is RH. It's just a different typing. And there's two types. There's a positive and a negative. Positive just means that on your red blood cells, you have a second antigen, a different antigen. This is called the D antigen or the RH antigen. RH comes from rhesus monkeys. So they called it that because they found this antigen in monkeys first, in the rhesus type of monkeys. So if you have the D antigen, you're positive. If you do not have the D antigen, you're negative. That's all. It's very simple. So me, I am a positive blood type. That means on my blood erythrocytes, I have the A antigen and the D antigen. That's what it means. So the best donor, the actual universal donor is O negative because negative and O means there's no antigens. If you're O positive, you do have the D antigen and you will cause a reaction in someone who does not have the um, does not have the antigen. So really quickly, what does this mean for let's say babies? So you may have heard of like blood typing being important in giving birth. So let's look at a condition. Let's say if the baby, okay, here, let's say the mom is a positive, okay, A positive. That means that she has the D antigen on her red blood cells. Okay, so she has the D antigens on her red blood cells. If the baby is um, a negative baby, and that is possible. Okay. So with a positive mother and oh, sorry, if she is a negative, okay, I'm doing this wrong. Okay, let's start over. Here's mom. Mom has an Rh negative. All right. And let's say the father is Rh positive. So in this condition, then they have to check the baby. Okay. Because in mom, her red blood cells don't have the D antigen. With an Rh positive father, it means the baby can also be Rh positive. It could be Rh negative too, and then there's not a problem. But if the baby is Rh positive, okay, what does the red blood cells look like? The red blood cells have the D antigen. And so what does mom see that as? She sees it as foreign, and she will attack the baby's blood. Okay. So that's one thing. If you're planning on having children, you're female, you need to know your blood type. Okay. A lot of people don't. And then, it's kind of something they do. They'll check your blood type because if you're Rh negative, you don't have that D antigen, right? There could be problems with babies. Maybe not the first one because it takes a while to build up your immunity against the D antigen. So with the first baby might not be a problem, but the later babies, yes, you will already be ready to attack the baby blood. This is called it's called erythroblastosis fetalis, like in the fetus, and erythro, it's uh, red blood cells, right? And they're going to attack the red blood cells, erythroblastosis fetalis, or there was another common name, but that left my mind. All right, so Rh positive dad, Rh negative mother, and can be a problem. So what do they do? If you are Rh negative, they give you a medication, and it's called Rogam, and it blocks the production of those antibodies. Okay, so that's important to know. And it might be something that you'll encounter in your work. All right, so let's now go back. Okay, and I'm going to bring an image that now will hopefully make sense. I didn't want to put it too early because it might be like, what the heck? All right, so let's take a look. Oops. All right, so here's just a depiction of this. Type A, type B, different antigen, A, B, and O. All right, now that hopefully makes sense. So this is another thing that I did not talk about is if if you have type A blood like this, you also make antibodies against the B antigen. So if I were to receive B blood, I would have antibodies that would attack it, right? So these are the antibodies that go with this blood type, right? Does that make sense? So I would make anti-A antibodies against A antigen if you put it in me. AB type blood, interestingly, doesn't have antibodies for A or B. So that's why, it's a universal recipient, okay? Because it doesn't have antibodies, right? Because it has those antigens. And then, O type blood has anti-A and anti-B antibodies. So if you're O type blood, you can only receive O blood because you put any of these in you and you're going to attack. You're going to make antibodies that are going to attack both of them. Okay. Let me see. Oh, there's one more thing that I wanted to put on here. Oh, yeah. About the RH. So, oops, I put this in the wrong place. I put my picture in the wrong place. There's a couple more questions. All right, what blood type is the universal donor, universal recipient? We already talked about that and explained why, right? Oops. Make this the right color. All right, so universal donor O negative, there are no antigens on it, right? Universal recipient AB positive contains all the antigens, so the doesn't produce, won't have antibodies. Okay. What is a CBC and what kind of information might it provide for healthcare professionals? So this is what you're going to see. You're going to see the tests that are done, and one of them will be the CBC. This is, and they take blood for everybody. So they do CBCs on everybody. Complete blood count. What does that include? A lot of things. Red blood cell count, hemoglobin, white blood cell count, hematocrit, which we already know. All right, so you're going to see all these things, and now you'll understand what it means. Yay! And for yourself, right? This is not just about your profession, it's about your own healthcare. Can you make better decisions based on knowledge that you are gaining? So, look at it that way. How can you better take care of yourself, your children, your parents, your grandparents, and things like that. So it's just, good things to know in general. There are conditions which I'm surprised I didn't put in here, but too much um, um, too much or not enough red blood cells, okay, not enough hemoglobin compromises your ability to carry oxygen. So that's anemia. So again, A means without or less than, right? So anemia is low red blood cell count, right? Too much would be polycythemia. So there's a condition where you can have too many red blood cells. So know that, that exists and there's terms for that. Poly means many, right? And A means without or less. So, all right. Thanks for your watch, and we'll continue with the cardiovascular system with the heart.